Okay, we got one more talk before we move into our coffee break. So our next speaker, Dave Clelland, is a system engineer for MBSI WAV, and Dave's got an interesting history here that he started learning basic electronics at a TV repair shop when he was only 13 years old in small town Saskatchewan, and then his actual wireless telecom career officially began with Alberta Gov't Telephones in mobile radio in 1980. So he's got a long history in wireless and phone. He graduated from NAIT as a top student in his class in 1987 and has worked as a field technician and engineer in wireless and fiber optic business development, structured cabling in the last 20 years in broadband wireless with companies such as Netricom, BreezeCOM, Alvarion, and Telrad. Dave, welcome to the stage. All right, there you are. Okay.
Thank you very much. We've since I came to this is the middle of my second year at MBSI, and we've kind of made education a priority for our customers. If there's something out there that you need to learn about a product, then I've taken under my own wing to take and come up with the training material, come up with the information, whatever it is that it needs to do. And every month for the past about 18 months or so now, we've been doing a monthly YouTube channel video called Tech Talk. And in this Tech Talk, I've taken and talked about all kinds of different facets of broadband wireless, and I'm trying to be as vendor agnostic as possible. And but if you get on our mailing lists, register on our site, and Nicole and Leah will take and make sure that you're informed of when the Tech Talks are. If you want to join them live, that's fine. And otherwise, they're on YouTube. You can watch them anytime. And I was been pleasantly surprised over the last little while here at CanWisp in Ottawa. I had quite a few people come up to me and say, "Thank you for producing these, and keep on doing it, because they're very informative." And I want to just take a moment just to kind of toot my own horn here about Tech Talk itself here. But today, it's interesting that we're talking about hybrid wireless fiber and wireless hybrid equipment. I want to talk about 60 gigahertz. I want to talk about the standard that's called 802.11ay, which technically from its definition is above 45 gigahertz. And we have, of course, unlicensed spectrum at 60 gigahertz. And so Cambium and Ciclu and a number of manufacturers have product now in the 60 gigahertz band that integrates a meshing system that was developed by Facebook called Terragraph. So Terragraph plus 60 gigahertz comes together, and we have this product, which I think that one of its strengths is that you can come into a small town or a rural subdivision, whatever it happens to be, and if you can't get fiber to the home in good order, you can take and capture these customers using 60 gigahertz, which right off the bat, as quick as you can deploy any kind of fixed wireless, this mesh, and begin to realize the revenue, own the customer, and the capacity on this system uses 2 gigahertz channels. So the current capacity of the system is about 3.5 gigahertz split in each direction over this system here. So let's go to the next slide. And this is kind of what the architecture ultimately could look like. There are 3 components in the system itself, as Terragraph defines it. There is an end-to-end controller that is managing the routes. It's managing the connections between the distribution nodes. Then we have distribution nodes that are set up and across the coverage area. Now at 60 gigahertz, range is really short because we're suffering from oxygen absorption and other propagation anomalies. So this system is really designed for about 100 to 150 meters between the distribution nodes. And then the distribution nodes will connect to each other. The specifications for the system allow for one distribution node to be connected to 2 more distribution nodes. And the way Cambium have brought it together, in this case with the, we'll see in a second here, is that each distribution node is actually 2 140-degree sectors. Uses beamforming to enhance the connection to each connection node, each or subscriber module that you connect to the system. But nevertheless, the system is designed so that we mesh the distribution nodes together, and then where the customers are, where the connection nodes need to go, then we'll take and as a network installer, you can use what I call installer diversity and pick the best connection then for that particular subscriber. So if the situation is such that you can only mount it on one end of the business or the house, then you can take and aim for the nearest distribution node from that point. If there's some, and it's got all kinds of diversity here. Let's go to the next slide. All right, so we'll run the end-to-end controller manages the routing mechanism. This is a layer 3 system, and in that the system uses IP version 6 to connect the distribution nodes and the connection nodes to the end-to-end controller. So Cambium have taken and kind of bent the rules a little bit and created their own type of IP version 6 system in it, but nevertheless, it's IP version 6, layer 3 endpoints all across the network. You can run the network as an IP version 6 layer 3 network. They also have taken and also managed by this end-to-end controller, you can flip the switch to make it layer 2, in which case then from every IP version 6 address, there's a GRE tunnel that's formed up. So now you have the GRE tunnels that are riding on top of this routed connection in between the devices. The routing protocol is called OpenR, and so the OpenR routing architecture is designed in such a way that the system is always looking for the shortest path from the shortest metric from a connection node to the device in the market that's called the point of presence. It's defined as the POP, as the physical exit of the data, if you like, leaving the marketplace. And so OpenR is continually working at making sure that the metric is as low as possible. The beauty of this 60 gigahertz system, if anybody's had any experience with it before, is that the device-to-device latency is generally less than 1 millisecond. And so across a market, even if you've got to make 3 or 4 hops to get from the connection node, the customer, to the point of presence, the latency on that network might only be 3 or 4 milliseconds right across that whole market. So it's very, very short, the latency. And we've got networks that are up here that are running now that have been in installation and production now for some months. That 700-800 megabits capacity to the little card size connection node, little small one, we'll see in a second here, is real common, really common, and 2 or 3 gigs between the distribution nodes is also a very common level of traffic here. So this system, as I see it now, as Dave's opinion, I don't think it's Cambium's opinion, but it's Dave's opinion, that one of the sweet spots for deploying this network would be that as you're doing your fiber build into a community, into a town, into wherever it is, I want to take and get these people, get customers connected right away. I can take and use the 60 gigahertz connections to take and bring people on right away. Then as next year or whenever it takes, however long it takes to finish the fiber build, I can take and kind of do that at my leisure. Then you pick up the 60 gig network and you move it a little farther out you move it. You keep and keep redeploying it. If you've got locations in the network that are difficult to bring the fiber to, there's nothing that says you can't leave the 60 gigahertz in place. Bring the fiber to, point at the end of the block, but you've got to go some distance farther, and you can extend this even more. Next slide, please. All right, little discussion of the OpenR architecture, how it generates the metric as to how it does this. Next slide. All right, there's the three devices that comprise the network. There's the distribution node, and then there's a long-range subscriber and a short-range subscriber. So the V5000 on the left is a two-sector, 140 degrees per sector distribution node. It is fed with either a 10 gig Ethernet or a 10 gig fiber, SFP plus, and it's got a 1 gig Ethernet auxiliary output, which can also feed PoE to a camera or to something else, whatever it is that you want to do with it. The three ports are bridged together normally. When you're building this network, you have the ability to say take two of those V3000 point-to-points in the middle, the connection node in the middle, join them together as a point-to-point, and extend the coverage from a V5000 through this point-to-point to another V5000 that's at the other end. There's a mechanism within Telegraph now that I can take this network and I can break that connection out of the bridge and route through that. So it looks like it's the point-to-point behaves just as though it were a customer link, as though it were a distribution node, and it just kind of homogenizes everything together and allows you this incredible flexibility in the system. Now the V3000, that's a 44 dBi gain antenna, so it's got about 3 or 4/10 of a degree of beam width. Aligning it up is by eye is very difficult. There's an optical tube that when you order your first units, you should get, all your technicians should have an optical tube that there's a little holder that fits in there, a little gun sight, and you can make your visual arrangement. And then within the GUI itself, inside the device, the technician would take and log in and then do the fine adjustment on the bracket. There's a fine vertical and horizontal adjustment in the bracket that you take and bring everything in line, and away it goes. The V1000 on the end there is the connection node that would be used the most. It's actually quite inexpensive, and it's about this big. About that big, and it has a gig E connection to it, so you can take and bring a gigabit connection into an individual customer. The V3000 and the V5000 all have the 10 gig Ethernet, the 10 gig SFP, and the 1 gig auxiliary out of both of those devices. Next slide, please. All right, so there's the coverage arrangement from the V5000, from the distribution node. So in fact, I can take and connect up to 15 devices to each one of those sectors. 2 devices on each sector can be another distribution node, and so if I'm taking this distribution node and connecting to 2 more, I would then have the room for 13 customers on this, as well as the being part of the mesh. Next slide. All right. So the connection nodes. Now the connection nodes, the way that Cambium has designed the software in these connection nodes, I can take and dedicate a connection node as a point of presence, or I can use a distribution node as a point of presence. So we'll see in another couple of slides here that the typical architecture is that I bring a physical connection, be it maybe an 80 gig 10 gigabit link, or maybe it's a fiber connection into the network at a particular on a particular lamp pole or whatever it is that I want to use for the distribution node for my point of presence. I name it that, and then as I go away from there, I would use a combination of connection nodes to achieve the coverage that I need. Now, because of the fact that my propagation attenuation is real high, from a distribution node to the V1000 to the little connection node, my maximum range is about the same as the distribution to distribution node, so about 150 meters or thereabouts tops. I can take the V3000 then with the higher gain antenna on it, and I can go about 400 or so meters. Sometimes they'll tell you that some tools will tell you that you can get more propagation out of it than that, but the reliability comes down real quick as you near the end of that length. And so my recommendation for people when they ask about how to do this, I recommend 400 meters between the distribution node and the V3000 connection node. I say 150 meters between the distribution node and the V1000. And then if I'm using two V3000s as an extender, as a point-to-point to extend away from it, I can set those up to 1 kilometer apart. So using that combination of equipment in a network, I can provide robust coverage across a fairly small area in fixed wireless terms, but nevertheless, I can come into a small town, for example, of let's say 200 or 300 houses, and I can set up a system with 15 or 20 distribution nodes, and have the opportunity then to connect everybody in the town. So it's pretty robust. It's reasonably inexpensive, and it's got this monster capacity, which is only going to get part of the roadmap. Is the ability for Intergraph to bond channels together. We have 4 channels that we're capable of using at 60 gig, and so at one channel, I can do about 3.5 gigabits in altogether, 1.7 in each direction. With 2 channels, I can double that, and so that's the plan for the future for this, is to be able to bond 2 channels together and aggregate that data. So as far as capacity is concerned, a system like this is kind of a revolution compared to some of the fixed wireless that we've been dealing with. And so this opens up all kinds of opportunities here. Fiber extensions, of course, are the first one. You could do a whole community on its own. Let's say that you're going into a competitive situation, or greenfield situation. You want to take and test the water. You can build a mesh network using CN-Wave here. Accomplish what you need to do, and see how many customers there actually are in there before you actually go to the point of saying, okay, well, we're going to fiber this, or we're going to do whatever your next plan is. This gives you that opportunity to say, okay, over this summer we're going to build this, over this summer we're going to test it, and then for next year, in the case Bob was talking about a 4-year program. So this gives you a little bit of flexible wiggle room in the middle of all this to be able to take and finalize what your market might look like in a particular area. Next slide, please. All right, so here's slide's a little busy for our little environment in here, but nevertheless, it talks about there are 2 different configurations of this network. If I'm building a small network, I can do the end-to-end controller on one of my devices. I can enable an onboard end-to-end controller and connect up to 30 devices to that end-to-end controller. If my market is going to be bigger than that, if I'm going to have more connection and distribution nodes than that, then I would use an external end-to-end controller, of which then I can take and connect as many distribution and connection nodes as I want to that, and have the end-to-end controller manage the OpenR routing. So there's the 2 configurations. We currently have both systems in service in different locations. For example, there's there's a company that's doing a network in Standard, Alberta. The end-to-end controller is located in a data center in Edmonton, and the E2E has a path out to Standard, Alberta, and then in Standard, Alberta, they got a single point of presence, and currently about 22 V5000s in there. And I looked this morning on the network, and they've got about 30 customers connected to that. And I looked in the history, and there were some people that were that at peak time were drawing 600 megs. So it's a pretty nice little arrangement. And they started building this about 3 months ago, something like that, right? So in 120 days, they've gone from having no service in town to having customers on and true fiber replacement kind of customers on, and being able to offer that kind of service. Next slide, please. All right, so there's what a typical deployment might look like. So we've got a case of DNs kind of mounted on a grid, and then we've got CNs that wherever they happen to be, they connect to the distribution node that's closest to them. We want to take and maintain as high a link quality as possible so that we pass the most traffic as possible. Everybody knows the rule about signal to noise ratio, right? The link quality, the higher the better. And this network is absolutely no different than that. When it comes to building the network, now there are some pretty nice tools out there that we can use to look after this, the design of this. Cambium. We have not very much LiDAR data here in Canada. Some areas have more than others, and so Link Planner, Cambium's free planning tool, is the tool that I've been using the most to be able to help our operators plan out these kind of networks. They also have a software called CN Heat, and this CN Heat uses LiDAR data, and of course, it creates a digital elevation model with the trees and the actual roofs of the buildings and everything else all in place. And so then you can get true indication of what's line of sight, what's not line of sight. At 60 gigahertz, of course, everything has to be absolutely line of sight. If this were a 60 gigahertz radio and I go like this, I stop the transmission, right? So I can't have anything in the way of this 60 gig. It's absolutely line of sight. And Facebook have a tool that's called Advanced Network Planner, and it's kind of the standard teragraph planning mechanism. But I can tell you that the network, because of its complexity and options that it has, we've done some small towns like this. We've done 20 versions of the project, 20 or more versions of the project with Advanced Network Planner, because I can take and set a budget. Let's say I'll say it's $300,000, and then it'll plan the network so that I spend $300,000 in the network. And oh, I got some coverage holes, or maybe I got DNs that are way too close together, so I want to reduce the budget. So I bring the budget down to 250. I run it again. I do this again, and it uses the LiDAR data and the terrain data number. It's quite complex to set up, but anyway, you get good results out of this. And in the time that from first release to now, the tools that we have to plan these networks have grown an order of magnitude. And so I suspect that within the next 6 or 12 months that we're going to get them that more complex again and simpler to use and everything else. But that's what I wanted to talk about today. I wanted to talk about introduce you to Tech Talk if you've never joined me on one of those, and to introduce the 60 gig as part of this hybrid wireless fiber type of application. So if you got any suggestions as to topics that you want to hear, just send an email to marketing@mbsiwave.com, and Nicole will take and forward me your requests, and we talk about this almost every week about what to do next, and At any rate, I appreciate your time today. Thank you very much for having me.
Thanks. So where can we find Tech Talk again? It's on YouTube.
It's on the MBSI channel in YouTube.
In YouTube. Okay, great. I'll definitely take a look. That sounds very interesting. Yeah, amazing to see that kind of fiber-like experience over wireless actually delivering. It sounds like in a real-world Canadian application. So that's exciting. Great. So we're now here at the coffee break. So we've got about just over half an hour. We'll start things back up again at 11:15. So take 35 or so and catch up on your emails, have a coffee, and we'll see you back here at 11:15. Thanks.